Welcome back, everyone. Today we're going to be terraforming Mercury. And I know that's a crazy idea. Mercury is far too close to the sun, I can hear many of you say. Um, but actually, it wouldn't be that hard. Now, I'm not a supporter of terraforming Mercury because Mercury is going to be an economic powerhouse of the solar system, being so close to the sun. It's actually the closest planet on average to all the other planets because it never gets that far away from the sun. It's always very close to the sun, averaging, I believe, 58 million kilometers from the sun. Um, but yeah, we're going to terraform it just for shits and giggles. Excuse my language, but just to show you that it can be done. Now, fun fact: a lot of people don't realize this. Mercury is or does possess the only other magnetic field among the rocky terrestrial planets of the solar system. Only Earth and Mercury have a magnetic field. And I think what's it called? Bepi Colombo, however you pronounce it, is going to be investigating why Mercury has a magnetic field. Now, its strength is only about 1% that of Earth's. Earth's magnetic field is 100 times stronger. So Mercury's magnetic field is completely overwhelmed by the proximity of the planet to. As you can see, it's much more intense. The proximity of Mercury to the Sun, it experiences much stronger and harsher solar wind than we do at 93 million um, miles away from the Sun. But it does have a magnetic field nonetheless. And that's kind of a mystery. It really shouldn't, based on our understanding of planetary formation. So, some scientists have suggested that its irregular orbit may be causing it to flex internally. There's a process called tidal heating where a world is stretched and pulled, and that internal friction, those atoms and elements rubbing against each other in the interior of a world, generates heat, just like a paperclip being bent back and forth. So that's the thinking, that Mercury's core must be rather molten. Now, what I'm doing here is Earth similarity 60%. That's interesting. What I'm doing here is I'm trying to add water to Mercury without that stream behind it. See how the water is just being blown away from the world, and you can see the numbers dropping in real time. Um, and I've raised the magnetic field. That was the strength of Earth's magnetic field, that 0.319. Um, so now we're triple Earth's intensity, and still, there we go, triple Earth's the strength of Earth's magnetic field, and it looks like we're still losing water. So the game might not be able to simulate. That's the size of it. We want the strength of it. So we're getting ridiculous. This is now 9 times stronger than Earth's magnetic field. Now, obviously, we can't do this to a planet. We don't have the technology to do that. That's still losing water. It really shouldn't be. You're talking about a magnetic field 9 times the strength of Earth's. It should not be losing water, because water, hydrogen, even things with mass, we're getting ridiculous now. And it's so it's still losing water. It is, yeah. So the universe sandbox is failing to accurately depict um, a magnetic field's properties, because a magnetic field this powerful would obviously prevent the solar wind from stripping water from the surface. Things don't, just because a gravitational force is weak, like Mercury's or the moon's, doesn't mean that matter is just going to fly off into space. Um, the Earth, a lot of people don't understand this. The Earth's gravity is strong enough to hold on to hydrogen and helium. It's the fact that the solar wind is stripping away most of our hydrogen and helium at high altitudes that we don't have an abundance of it in our atmosphere. The atmosphere is not homogeneous, it's not consistent all the way through. At ground level, you have your much heavier elements like carbon dioxide, and as you go up and up and up, you have lighter and lighter elements. Eventually you reach a point in the Earth's atmosphere where oxygen and nitrogen are no longer the dominant gases, but hydrogen and helium are. So, um, anyways, I'm trying to. So we've got to give, to terraform Mercury, we've got to give it an atmosphere, obviously. And I changed the mass because that's the only way that Mercury is going to hold on to any water, unfortunately. Universe SANDBOX is a wonderful simulation tool. It's not perfect, though. That's why you have a lot of people on YouTube that they make these cute, fun videos, but I really kind of don't like them because they're spreading disinformation. And I strive to be a little more accurate. I might not be as flashy and entertaining. In fact, I know I'm not, but that's cool. We got a little ice on the surface now. Yeah, in fact, I know I'm not as flashy and entertaining. I don't do jump cuts. Every 5 seconds, throw some wacky TikTok sound effects in there. God, I'm sounding like my dad, but I just honestly, God, if I could be honest with y'all, I freaking hate that stuff. I cannot stand watching a video and there's constant little TikTok sound effects. I cannot stand it. I'm not an idiot. I do have a personality. I do have a sense of humor, but to me, there's just nothing funny about constant noise and distraction. I'm trying to learn something when I watch videos like these. I'm not trying to, you know, hear Looney Tunes sound effects every other second. So now you'll notice as we raise the water level of Mercury that there's no clearly defined oceans. And this is because Mercury really lacks like mountain ranges or like Mars, you have a lower hemisphere. The northern hemisphere of Mars is much, much lower than its southern hemisphere. So you would have seas that build up. But you notice, like with Mercury, there's, I guess you could call seas, but no real oceans. There's and every landmass is pretty much a crater rim. Now we have some city lights up top. That's pretty. Um, and in all honesty, terraformed or not, people are going to live at the poles because the poles is where you have access to constant sunlight. You also can regulate incoming sunlight so that you don't cook. You can set up a permanent colony up there with Windows Smart Glass that adjusts how much solar energy you allow into your structure. It's actually at the very tippy top and the very bottom of Mercury. It's actually extremely cold because there's not enough solar radiation reaching the world. And in fact, it's in some places it's same as our moon. There's what they call permanently shadowed craters. There's places that the sun just never reaches because, like our moon, Mercury has no axial tilt. So, but you'll notice that the average temperature is much, much higher than Earth's. Now I'm gonna speed things up because it takes a little while for temperatures to finally stop climbing. Obviously, 130 Fahrenheit and still climbing is much, much too hot for human beings. Yeah, we're already up to 170 and it just keeps climbing. So now I did give Mercury about 40% of Earth's atmosphere because as I've explained in other videos, we don't actually, when terraforming these worlds, we don't actually need to create a full bar of atmosphere. A bar is Earth air pressure at sea level. Anybody living in higher elevations where the air is thinner, they get very, very used to it. The tippy top of Mount Everest, you've got about 0.35 bar. So, that's, if a bar is 100%, then the tippy top of Mount Everest, you've got about a third of the atmosphere. Now, there's something called the Armstrong limit, where there's a certain amount of pressure that's absolutely required, or your blood will boil. So, yeah. Anyway, you'll notice I'm trying to change the luminosity now, right? So the luminosity being at, hang on, give me just a second. We can lower the luminosity of the sun, which simulates a solar shade, either dust at the Lagrange point between the sun and Mercury, or a permanently artificial solar shade, something that blocks incoming sunlight from reaching Mercury. And just like Earth, every world in the solar system has Lagrange points where the balance, the gravity, the pull of the sun is balanced out by the pull of Mercury, and you have these regions in space where essentially things can park. That's where our James Webb Space Telescope is. It's in a Lagrange point. It's a very stable point, because you are basically using two worlds to balance out your position in space. If there wasn't the pull of the sun, if there was just Earth, then eventually, even from great distances, an object would be pulled towards Earth. I'm showing you the difference between the cold and the hot. So the hot is extremely hot, and the cold is, of course, inhumanly cold. What we want is this little region right, I was just pointing to it, right where the green becomes light blue. That is the temperate zone. That's what we're used to here on Earth. Now, it doesn't stay the same, and that's why we would need to regulate windows and things like that at the pole, because there is a slight axial tilt to Mercury. Not much, but there's a slight axial tilt, and that axial tilt is going to cause any structure to become way too hot. Now, if we reduce the luminosity of the sun by 75%, so now, of course, like Earth is going to freeze. There's only a quarter as much light coming from the sun, but we wouldn't actually be changing the sun. If we terraform Mercury, what we would do is create, like I said, a sun shield, and we would block incoming sunlight from reaching Mercury if we wanted to terraform it. And that's and honestly, if we may say, oh my god, what a stupid idea to terraform Mercury, because its airless atmosphere and low gravity makes it ideal for shipping materials off the surface. But Mercury may become so wealthy at some point, or we may perfect the technology of actually mining the sun for resources, because the sun has more resources than anything else in the solar system combined. Obviously, there's more metal, there's more silicon, there's more calcium, you name it, in the sun. The sun is where the vast majority of elements are. So yeah, I'm checking the temperature, and we are still pretty hot. An average temperature of 90 Fahrenheit is it's a little uncomfortable, but you can see it's dropping a little bit as Mercury moves away from the sun, and then looks like it's raising back up as it gets closer. So, it as stupid as it may sound to terraform Mercury, the people of Mercury might become so fantastically rich that they don't want their world exploited. Yeah, and I know the sun's going to grow, and eventually it's going to totally consume Mercury and Venus and possibly even Earth, but you're talking billions of years in the future. And honestly, there's hope for Earth too. Let's say, uh, you know, let's say technology gives us more and more powerful technology. Technology gives us more and more powerful technology. I'm having those brain farts again. Um, Technology gives us more uh, equipment that uses more and more energy. It really doesn't matter how little carbon dioxide we produce if our personal energy consumption continues to climb. So, thank you for watching. Leave a like, please.